Hey everyone, and welcome. Today, we are diving deep into a technology you're probably seeing on rooftops all over the place, solar panels. We're going to pull back the curtain and figure out exactly how these things turn simple sunlight into the power that comes out of your wall sockets. All right, let's get into it.
You know, when you really stop and think about it, it kind of does seem like magic, doesn't it? I mean, you've got this flat, silent panel, there are no moving parts, it's not burning any fuel, it's making no noise, it just sits up there soaking in the sunlight and boom, out comes electricity. It's just an incredible piece of technology.
But of course, it's not magic, it's science. And that leads us to the big question for this whole explainer. How in the world do you turn a sunbeam, just a little packet of light, into the electricity that powers our lives? Well, let's find out.
So, we're going to start by unveiling the science behind this solar miracle. It all comes down to one core idea in physics, a phenomenon that's known as the photovoltaic effect.
And to really get it, we need to zoom in, way in. We're going to go right inside the fundamental building block, the absolute engine of every single solar panel, the silicon solar cell.
Okay, so this whole amazing process, it basically boils down to 4 simple steps. First up, these little packets of light energy called photons come flying from the sun and they smack right into the silicon atoms in the cell. Then, that impact has enough oomph to knock electrons loose from those atoms, and here's the really clever part. A built-in electric field grabs those free electrons and starts shoving them all in one direction. And bam! That organized flow of electrons, well, that is electricity. Specifically, it's direct current, or DC power.
So you might be asking, how does the cell even create that electric field in the first place? Well, that's the absolute genius of something called the p-n junction. Engineers cleverly add different materials to the silicon, and that creates a permanent built-in electric field. The best way to think of it is like a one-way street, or maybe even a slide, just for electrons. Once they get knocked loose, they have no choice but to travel in one direction. It's this brilliant little piece of engineering that turns a cool physics trick into an actual, usable power source.
Okay, so that's the science lesson. That's what's happening at a microscopic level inside every solar cell. But how does that translate to the real world when you're looking at an actual panel? Well, that's where the spec sheet comes in. And yeah, it might look like a wall of jargon at first, but it's really just your guide to how that panel is going to perform. So let's decode it and turn that tech speak into stuff you can actually use.
The very first number you are always going to see is Pmax, which stands for maximum power, and it's measured in watts. Just think of this as the panel's horsepower. It tells you the absolute max power the panel can kick out. But, and you got to remember this, that number is only achievable under perfect standardized lab conditions.
Next up is module efficiency. This one is huge. It's just the percentage of sunlight that hits the panel that actually gets turned into usable electricity. So picture this. The sun is just blasting the earth with about 1,000 watts of energy for every square meter. An efficiency of 20% means your panel can grab 200 of those watts and turn them into power. So yeah, higher efficiency just means you get more power from a smaller area. Simple as that. And this brings us to a really important point. The lab is not the real world. STC, or standard test conditions, that's your perfect lab rating. Cool temperatures, precise lighting. But NOCT, that gives you a much better idea of how the panel's going to do out on a real roof, where it gets hot. Heat is pretty much the enemy of efficiency. So the NOCT numbers are always going to be lower than STC, but they are way more realistic.
Now, not all solar panels are created equal. The technology has come a long way, and now we've got a panel for pretty much any purpose you can think of. So let's break down the main choices you'll find out there on the market.
All right, so the 2 big players, the workhorses of the solar industry, are monocrystalline and polycrystalline. Mono panels, as you can see, are made from a single pure silicon crystal. That's what gives them that sleek, uniform black look and, more importantly, higher efficiency. But they do cost a bit more. On the other hand, you have poly panels. They're made from a bunch of silicon fragments all melted together, which gives them that classic marbled bluish look. They're a little less efficient, but they're also cheaper. It's that classic trade-off, right? Top-tier performance versus a better price tag.
But get this, the innovation is not slowing down at all. Look at this next wave of tech. PERC technology adds a special layer to the back to literally capture more light. TopCon, it's a newer design that's a beast in high heat and low light. And then you have bifacial panels that absorb light from both sides. How cool is that? And of course, there's flexible thin film for all sorts of unique jobs. The industry is just constantly pushing what's possible.
Okay, I know what you might be thinking. With all this fancy tech inside, how do we know these things are actually going to last for, 25 or 30 years out in the real world with sun and wind and rain and snow?
Well, that is where the science of reliability comes in.
Solar panels go through an absolutely brutal series of tests before they can ever be sold. I mean, they get frozen, they get baked, they get blasted with artificial hail, they're sprayed with corrosive salt mist to make sure they can survive anywhere from a scorching desert to a breezy coastline. They even get a special X-ray called EL imaging to find tiny, invisible microcracks that might cause problems years down the road. The takeaway here is, these things are built to last. Period.
So there you have it. We've totally demystified this, right? We've gone from seeing a solar panel as this sort of magic box to understanding that it's a super sophisticated but totally understandable, reliable machine. You now have the keys to understanding this amazing technology. You get the science now, you know how they're measured, you know the difference between the lab and reality, you even know about the different flavors of tech that are out there. So the only question left is the most exciting one of all. What could this technology power for you?